All right, this is a welcome video to the beginning of the top 10 chapter. What this chapter is about is covering the top 10 targets that have been covered in Algebra 2. And our goal today is to look at the first two targets, those targets being sequences and functions. The rest of those will be covered in the following days. A quiz will follow after target 5, another quiz will follow after target 10, and then finally our final test will come right after that last quiz with our final test covering all 10. Good luck, and I hope this video helps get you through the first two targets. Here's how it starts. First, before we get going here, we need to review our notes on arithmetic versus geometric. Arithmetic sequences, they add, and the geometric ones, they multiply. If you're ever looking at a sequence and you want to figure out what is it doing, if you simply just go next minus previous in two different spots in the sequence and you get the same answer, you'll know it's arithmetic. If you do next divided by previous in two different spots of the sequence, you'll know if it's going to be geometric, if the answers come out the same as well. So you test geometric by going next divided by previous, and you test arithmetic by going next minus previous. And the next thing is, if you wanted to try to find the equation of these kind of sequences, remember the first number that you see here is the first term. So when writing the equation, you got to go backwards one spot to find the zero term. So on this first one right here, you'll notice that it's adding 4. If it keeps adding 4 going forward, you have to subtract 4 going backwards and find your zero term, or your starting value. Once you have the starting value, you can then look at the format here. It says you write your starting value plus the adding amount times n. In this case here, it starts at -1 and then it adds 4 n number of times. This next sequence on the right-hand side that goes under geometric, if you take 9 divided by 6, next divided by previous, you'll get an answer of 1.5. That's what it's doing as you move forward, but if you want to find the equation, you have to move backwards from the first term and find your zero term of 4. So when you write the equation for a geometric, you say, what does it start at? And what's your multiplier? Well, if this thing starts at 4 and multiplies by 1.5, then it's t of n equals 4 times what you're multiplying by, 1.5, to the power of n. Always recognize that arithmetic is times n, and geometric is to the power of n. Next, there are some sequences I want you to try in the slideshow here if you'd like to look through them, and they have different solutions here. I'm going to fast forward so you don't see the solutions too much. But the following thing is we're going to follow that with functions and function notation. You'll notice when we write an equation like this, it says f of 3 equals what? That 3 is an input. You put that 3 in for the x squared that you see right here. So as I do this part right here, you'll put 3 in for x and it becomes 3 squared. Put this directly into your calculator, or recognize that 3 squared is 9 times 5, which is 45, and 45 minus 1 gives you 44. The same thing goes for the second one. That -4 is an input, and then what you need to do with that also is recognize when you put that in with your calculator, if you don't use parentheses, you will not get the answer of 79. So it's important to use parentheses, so that when you square -4, you'll get a positive 16, and 16 times 5 is going to give you 80, and 80 minus 1 is 79. So these kind of writings like this are both inputs. Lastly, if you see it saying f of x equals 19, that 19 is an output. In other words, then you're going to take the f of x function and set that f of x function equal to 19. And as you do that, you'll solve that by subtracting 19 to both sides, and then use the quadratic formula as one option, or you could just simply isolate the x squared and then eventually square root both sides and get the same answers of 2 and -2. That's all we have for those kind of problems. You're going to either have inputs like you see in the first two, or the 19 is an output, and if it is an output, you set the function equal to it and you solve it like an equation. Lastly, we're going to see what is called a composition of functions. You're going to see a function that's nested inside of another function. The way this works is that 2 is still an input like it was in the previous slide, but this 2 goes into the f function first. So you're going to put 2 into the f function first. That's 2 times 2 and then -1. And then eventually that gives you 3. As you take that answer that you get out of 3, then that 3, which is the next answer you're going to put it into, is the g of x function. Notice how it's structured here. 2 goes into f, and the answer from the f then goes into the g. And if our answer from the f is a 3, we put 3 in both the x squared and the x spot, and then 3 times 3 squared, which is 3 squared being 9, 3 times 3 squared is going to give you 27. 27 plus 3 gives you then 30. This is what a composition of function looks like also. And that's basically it. What we need for you to do next is to try to open the homework and see if you can apply these things of sequences and function notation, and hopefully remember what you did from way back in the first trimester of our school year. Good luck.